All right, numeric response number 7. The critical numbers for the function, and you got the function right there, are blank and blank. Okay, well, question tells me that I'm going to get 2 of them. Now remember what you got to do here. The critical numbers are values in the domain of the function for which the derivative of the function is either 0 or undefined. Okay, now let's just take a quick look here. Is there any place where this, well, that's right, I should ask it like this. Take a look at the function and just consider the domain here. And I believe the domain in this case is going to be all reals. There's really nothing there that should cause me any kind of grief. I'm taking cube roots, which are fine. I can take cube roots of negative, that's fine. And the exponents here aren't negative, so there's no rational, there's no at least explicit rationality to that. So first thing I'm going to do is take the derivative, and in here I'm going to get 5 x to the 2/3 minus, okay, well I'm going to bring the 2/3 down, so a third of 15 will be 5 times 2, there's going to be 10 x to the negative 1/3. Okie dokie. Okay, so now all of a sudden I've got this little rational bit here. So what we're going to see here, this is going to be 5x to the 2/3 minus 10 over x to the 1/3. Okay, I'm going to put those two together, and I'll explain why in just a minute as soon as I've done that. But my common denominator here is going to be x to the 1/3. The second term will be minus 10. Now that first term in there, if when I multiply this, I'm just simply going to get a 5x. Okay, now the reason why I do this here is because our critical numbers can essentially be looked at in this context here. When I've got a rational expression like this, it's either going to be where the numerator goes to 0, okay, which would be where the whole function goes to 0, the whole derivative goes to 0, or where the denominator goes to 0, which would make this expression here undefined. So the two critical numbers that I'm going to end up with here, okay, the numerator is going to go to 0 when x is equal to 2, and then the whole expression will be undefined when the denominator goes to 0, and that is, in fact, where x is equal to 0. So the two critical numbers here are going to be 2 and 0, and those work. First of all, they're the only two that we found, so that has to fill in those blanks. And again, the original function, the domain was all reals, so there was nothing that I needed to reject as an answer.